Today we're going to cover the Tabulate app and Solve plugin in Pyramid's Decision Intelligence platform. To begin this conversation, we're going to start with a broad conceptual overview of what Pyramid calls the data factory for decisions. The data factory can be broken up into two segments. The first is data prep and data science, and the second is analytics. When you deconstruct these elements of the factory, we can better understand how Pyramid itself is constructed and where the Tabulate and Solve capabilities fit into the picture. To begin with, in a generic conceptual sense, a typical customer of analytics driving decisions will start with raw data. They may or may not need to fix and clean it. Today, as is becoming more and more appropriate and necessary and required, they will apply data science and machine learning through DSML modeling and application. And finally, they will attach a semantic model onto it, which allows end users to interrogate the data with point-and-click efficiency without having to know how to write code or anything of the sort. And this is exactly what Pyramid delivers in the data prep and data science domain and discipline. Of course, customers may come with curated and perfected data warehouses, data lakes, databases, data sets, whatever word you want to use. Or they may even come with a pre-configured semantic model with data embedded, say from a Microsoft OLAP cube, an SAP BW info cube, or BEX query, and in which case you won't need to use most of the elements of data prep and data science. From here, the data and the newly formed information needs to be consumed. And this is where we move on to discovery and logic. This is where users start to discover the data, play with it, analyze it, interrogate it. They might use it to create descriptive visualizations of the data. They might use it to diagnose what's going on inside the data and bolt on data-centric logic, formulas, analytical structures, and general ways of calculating things, but very, very much centric to the data itself. Something that is not often talked about, but is very, very much front and center in the industry is a need to do business modeling, which is effectively taking data and merging it into business processes that are not uniquely or exclusively within the data itself, which is a strange thing to say because most people think that data and business modeling are one and the same thing, but they're not. And there's plenty of evidence for that, which I'll get into later. Optimization, of course, is the very elevated version of the consumption of data and analytics. It's where you start to prescribe what you should do with the data in an optimal fashion based on a certain targeted outcome that you're trying to achieve. And then last but not least, in the analytical realm is where you consume it for very, very much non-technical downstream users and deploy it, typically through interactive dashboards with live data, and of course through static content that might have been bursted out with personalized data sets and personalized analytic narratives to many, many thousands of users. This is what Pyramid thinks is the overall factory for decisions, and in effect is what Pyramid offers as part of its platform and its solution. So to marry it up with the apps in Pyramid, we have Model, which is Pyramid's app for doing data preparation. Embedded inside it is the data science architecture, since about 85 to 90% of all data science activities should happen in the data preparation stage, where you train a model, apply a model, and prepare it for consumption. Then we move over to the Discover app, which is very much earmarked for ad hoc query analysis, slice, dice, drill down, and whatnot. And it's also the location where you might build analytic assets in the catalog that will be used downstream for other things like the business modeling and the interactive storyboards, dashboards, and report bursts. Pyramid also has a Formulate tool, a Formulate app, which is a graphical tool for building very advanced and sophisticated business logic, lists, KPIs, custom visualizations, and whatnot. And the key thing about the Formulate is it's very, very much data-centric, which means only about applying that kind of logic to existing data sets, queries, and models. Which then leads us to business modeling. As I said earlier, this is where people bring in things that go above and beyond the data itself. We'll get to that in a second. But at the very end, people then need to design and create dashboards and storyboards at different elevations of these two similar concepts through what we call a presentation tier. That's interactive live querying for users. Publish, which is the ability to create pixel perfect curated publications of content, multi-pages, lots of queries, and then have that bursted out to many thousands of users, again, with personalized data per person or per recipient. And then an illustration tool, which allows users to create data-driven infographics, natural language generation from querying results, and blending that back into the present and the publish toolset. And that, of course, brings us back to the business modeling, which has been the gap all along, which is where the Tabulate tool appears. And within Tabulate, we have the Solve plugin, which is driving the optimization engines. So this is where Tabulate fits in, and it completes the factory in terms of going from soup to nuts and answering all the problem sets that are part of a customer's typical life cycle of building, of taking raw data and taking it and driving it into actual decisions for your organization and users. So the question is, why Tabulate? Why is this business modeling such a necessary feature? Where does it come from? And in fact, it's actually been there all along. It's been in front of us for many, many years. I think most people are in denial that it's actually a need, but the reality speaks otherwise. So what we call last mile analytics, the last piece of the analytical picture or analytical puzzle that is not filled, and it's driven from the following analysis. So Pyramid commissioned a very broad survey of data workers going to all kinds of users, not Pyramid exclusive users, many, many users. The key is that they had to be data workers who use existing BI and analytics tool sets. And we asked the question, how often do you go to Excel and how often do you do it? And the numbers were shocking. Over 50% of users export the analytical content from all these very fantastic visualization or formulation experiences, and they do it more than 50% of the time. Further, they tend to use the desktop application extensively. Over 90% of the time, it's using the desktop application. And this represents an interesting insight into the gaps that people are trying to close. They go above descriptive, diagnostic, analytic tool sets across the board. Further than that, when asked why they do it, these were the top 4 or 5 reasons. The first was, well, we need to use Excel formulas to add and imbue the data with business logic, which is a very interesting insight. So despite having a lot of horsepower and designing very complex and advanced data logic and formulas on the data and the queries itself, there was an extra layer of logic needed to inject into the framework that is not exclusively and uniquely around the data itself. It goes above and beyond it. And this is something that we at Pyramid call business modeling. We'll get into that a few minutes later from now. Another big reason was to blend results from multiple queries, which was interesting as well, because a lot of tools, including Pyramid, offer very advanced data mashups. And what we found is that, yes, people wanted to use the data mashup tools, and they're very accomplished. But that tends to be wholesale. It tends to be done at the data layer before you consume it in the analytical realm. Whereas what people were doing in Excel and are doing in Excel is much, much more specific. It's much smaller. It's actually the blend of query results in far more advanced ways than just, joining two sets of tables together by one unique key, something more advanced than that. Based on this, they also were building visuals of the blended data and the business logic. They were, to some degree, reformatting data. I think this speaks to tools that offer very good graphical visualizations, but weaker grid visualizations. And last but not least, using specialized tools in Excel, namely things like the solver. That's a very good example. Some people were using the pivot tables, which speaks to a weakness in the analytical platforms, and a bunch of other plugins that go with it. So it's a profound understanding that despite all the tools coming to market, from things like natural language querying to, AI-driven analysis, automated insights, all these kinds of fancy tools, such a large percentage of users are still needing to use Excel. And the pain points are the business modeling, query blending, to some degree data reformatting, and other specialized tools. Bottom line is, this creates a whole bunch of issues. First of all, it speaks to tremendous inefficiency in the data factory pipeline. If you don't plug this, you've got a problem. By using Excel to a large extent and Google Analytics to a much lower extent, especially in the commercial world, it definitely is a driver for spreadsheet help. The proliferation of hundreds, if not thousands, of Excel spreadsheets buried within being data and logic. This, of course, leads to the issue that we have a tremendous leak in the governance model and data security. When it's inside the analytics platform, you have a much better opportunity to secure the data, secure the logic and centralize it. And when it goes to a spreadsheet, it goes the diametric opposite direction. It's highly distributed, idiosyncratic, no control. You have no idea what's going on. And then fundamentally, it destroys the single source of the truth with all of that set in mind, right? You turn up to a meeting and 5 different versions of the same logic in 5 different spreadsheets. Or worse, you yourself have 5 different spreadsheets and you can't remember which one is the actually pivotal way to understand a certain business problem. So with all of that, Pyramid solves it through the Tabulate and Solve tool sets. Tabulate fundamentally is the venue for delivering business modeling. It's a browser-based virtual spreadsheet without using any Excel components, both client side and the browser and the server side. It involves live data. That's the big revelation. The data inside the spreadsheet experience should and would be mostly live data. Of course, users can always type in data. Yes, you can import existing spreadsheets with their formulas into the tabulated experience and it will be reflected perfectly back. But the key thing is that the whole experience will allow the user to do the business modeling tier with Excel-like formulas. You can do the query mashups. You can do visualizations on the multiple queries. The queries can come from one or more data sources that have to be from one only. And then the ultra flexible formatting. And I don't mean, fonts and colors and stuff like that. I mean, completely redesigning the grid, moving cells around completely. That is completely unrelated to the underlying queries that are offered. And Pyramid today has a very, very powerful grid formatting capability and general visualization capability, but you simply can't, deconstruct the query as you would in Excel or inside a spreadsheet, and certainly not blend it with multiple query sets together. You have complete, utter flexibility there. But all of that is dwarfed by the real revelation of Tabulate, which is that it's going to help many customers kill off the spreadsheet help problem, because the Tabulate content can be embedded in live dashboard and storyboard presentations, as we call them in Pyramid, with the live data. And so there'll be no need to actually, send out the spreadsheet to anybody anymore. Just the fragment of the spreadsheet that is needed for the non-technical consumer of that spreadsheet. That's all that needs to be now embedded in the presentation. And it can also be likewise embedded in the publishing tool for the report versus content to your many thousands of users who are not going to log in. The Solve tool delivers what we call decision modeling. Decision modeling is the process of coming up with a decision through a waterfall of different concepts and ideas. In effect, this is a big chunk of what prescriptive analytics is about. It's a modeling tool for coming up with the decision. Yes, this is what you should do tomorrow to achieve whatever business goal you have set. The key thing is it provides a no-code optimization UI and tool together with a backend engine. We're there with the Solve tool to solve decision optimization problems. You can actually drive real what-if analysis. I don't mean, the shares go up and the shares go down. I mean, driving very complex cascading logic. Ultimately, it can drive simulations through something like a Monte-Carlo analysis as well. And all of that is part of the Solve framework. The key thing is that the decision modeling can be expressed through the spreadsheet UI, which is still the most prevalent way for building decision models. And then, of course, by its very nature, sitting inside the Tabulate framework piggybacks the business modeling solution. Again, it's driven off live data. So yes, you can have a prescriptive analytics what if engine that is completely driven off fresh hydrated information that it can even be secured by each user who consumes it, so you get a different outcome per user. And last but not least, much like Tabulate, it can be embedded inside live presentations or report bursted publications, and by definition, it is shareable. And that is, again, a huge lift from the existing frameworks that deliver solve and optimization-based technologies, which tends to be for very, very advanced users who then have to go through the extra layer of sharing it in some format. This is seamless, integrated, live, hydrated, governed, secured. The list goes on and on. So without much further ado, we're now going to begin two demos, one for Tabulate, and the second will be for Solve. So to begin the first demonstration of Tabulate application, we're going to start by doing a simple query blending example. To demonstrate this, I'm going to start by using a discovery. Go full screen here. And opening up an SAP BW info cube. And for instance, I'd like to look at customer data using just two simple metrics. So not the most exotic example, but an example nevertheless that demonstrates a simple query that I might want to run off SAP. I like what I see, so I hit the save button. I'm going to come over here. I'll save it over there, and we will call it BW customers. At this point, I would like to blend this information together with an independent survey of these customers around their satisfaction around our service as a company, and see if there's any correlation between the amounts sold, the orders, the quantities ordered, and satisfaction. So for that, I'm going to begin a new tabulation. And the first thing I'm going to do is drag my SAP BW query into the mix. You can see it's immediately loaded into the browser. I'm sorry, into the spreadsheet interface. If you look carefully, you see the formulas are wired directly to the interface. If the data changes or I slice and dice it, the data inside the spreadsheet experience will update accordingly as well. Now, for the next part, I'd like to bring in the satisfaction survey data, which I happen to have already built previously. And if I come over here, you will see it over there. See it come in, and you'll see this coming in here. In fact, if I went to the data sources menu, you would see there's your SAP BW, and here is your satisfaction survey, which was read off, for instance, the Survey Monkey data set and loaded into a database, in this case, Pyramid in-memory SQL database engine. Of course, I've now got the two data sets side by side, and I'd like to get a single visual out of it that brings the two together. How do I do it? Well, off we go, and we use the typical VLOOKUP functionality that all of us interested and are used to inside Excel. You can see here in Pyramid, we expose the entire function library that is found in Excel, all 550 odd functions. And I'm going to use the one that everybody knows well, VLOOKUP. Fill it in. The value to look up is that. The table array to look up against is going to be this one. Fill that in, and we'll lock it so that we don't forget it. The index to bring back is number 2, and I want it to be a perfect match. That's going to be false. I hit apply, and the function is written over here. Of course, I could have done that to the formula bar as well. I didn't have to do it like that. I could have done it in line, but I wanted to show you how that looked. With the wizard, there it is. I'm going to double click to take it all the way down, as you would do in Excel itself. And we're going to call this satisfaction, and just quickly paste the formatting over. So there you go. I've got now one grid that represents the accumulation of these two queries. If I was to highlight these guys over here as one single grid and then right click and say, I want to visualize it as a scatter plot, I'll do that. And effectively, it's blended all three metrics plus the customer details into now as a bubble chart. And I'd also like to use satisfaction to drive coloring as well, just so I can get a better sense of how that looks. Let's format our little visualization a bit more. I want to center the axes, put a reference line in, and I'm pretty good with that. That's a very good example of me taking two queries, blending it together with a little bit of Excel magic and getting the results. Could I have done this through data prep and a data mashup? Yes, I could have. And I think that's more infrastructural. It's someone trying to do something a little bit bigger, a little bit more sophisticated. You're going to do it because actually you're going to repeat doing that over and over again. Whereas here at the query layer, it's quick, it's fast. It gives me some kind of flexibility how I interpret things, and allows me to do something. Admittedly, you can do it in both places. This is something that a lot of people are doing anyway in Excel, and why you would want to do it here. So I like what I see. I hit the save button, and my, see, I've done this demo before. You can call it, satisfaction on sales report is now done. So that's one example of how we can bring those things together. Let's close out and move to a second example. And this one, I will walk you through the entire life cycle of the process, from raw data to querying to tabulate, and ultimately to some kind of solve solution. So switching over to a different instance, which has got a different data set in it. I'm going to begin by opening up a data set that is known as the pollution demo, because it's got a bunch of data in it, in this case coming from just Excel. So not the most exotic example of data prep and data ingestion, but nevertheless a data set that is coming externally. This data set has information on different assets in a power grid setup, emission standards, pollutant standards, regional settings, and a whole bunch of things and stats around what is needed, including the data that would allow me to drive, using predictive logic, what might be the required power output by region, so I can project what is needed per region. If we go to the data modeling stage of the semantic modeling, we can see the way the tables are grouped together. There's a classic semantic layer with different metrics showing up. These are all done with averages, because we don't want to accumulate capacity or cost per megawatt hour. We want to average it. And obviously we're looking at the grain, it'll be the actual number that makes more sense, and so on and so forth. You've got pollutant levels, limits, and so on and so forth. So quite an evolved little model, despite it being from an Excel spreadsheet. At this point, what would I typically do? Well, typically I would go ahead and I would discover it. So let's say I've just gone up, run the model already, skip that from this example, and I come in here and I go, I'd like to see by region the cost per hour and the total capacity that is available. And if I was to break it out by asset and stick that over there, we get a slightly different view, and we can do a whole bunch of clever things with stuff. And it basically is just a way to consume information and see what's going on inside a little database. So that's what that looks like. And here, I guess you can see it by asset name and so on and so forth. And if I throw the sources over there, and maybe use that to drive the coloring, we can see the different types of sources doing what they're going to do. And that's interesting. This is a very basic, but a typical example of descriptive analytics, seeing what's in your data and understanding what's going where, how, and what. And of course, I could come along over here and do the usual bits and pieces and sort by that to see what the most expensive is. And, so the sourcing on the side, so we can see that as well. And look at that, the solar and the wind are still the most expensive. These are renewable but new energies, and they cost a lot more to set up than any of the fossil fuels and whatnot. Okay, good to know. That's what you would expect. So that's going from some kind of a raw data set to a discovery, descriptive phase. And now I'd like to get a better sense of how this all glues together to understand what my power consumption may or may not be, and then optimize it at some point. So for that, I'm going to open up a Tabulate session. And again, we're back into the spreadsheet interface. And using some examples that I've created previously, I'm going to read in a query here called capacity, which is effectively, again, the capacity by source. This is the total capacity, and this is the cost per hour. Again, these are averages because there are multiple assets inside that. Next to that, I want to see the emission standards, again, coming from a different, from the same data model, but a different query. This is source, emissions for each kind of source and the level that is generated. I'd also like to get the limits. These are the standard limits that are required for each kind of pollutant. Last but not least, I'd like to have a capacity target. This is what is expected. This came out of a predictive model to guess, based on the other data, how much power I'm going to need. And if you look at it all together, this is collusive across all regions. What I'd really like to do is understand it by region, so I can come along into this thing and say, listen, yeah, I'd like to add a slice to this, and now see all of the data by each of the 4 regions. So if I look at North data, you get a slightly different picture. If you look at it by South data, again, it changes. You'll notice that the cost per megawatt changes, the capacity changes, the pollutant changes, the limits change, and also the targets were probably different standards, different populations, different technologies. Who knows what the reason is? This is why it's what it does. Okay, good. At this point, I'd like to do a little bit of what if analysis. So let's copy the source out over here, like that. And let's type in for, cost per hour, something like that. Let's type in quantity, like that. And I'm going to get something called total cost over here. The cost per hour is simply just a lookup from this table, just to get into one little grid. That's how I'm going to look at it. The quantity is going to be, we're going to take a number over here. We'll do like what if GTY, and I'll type in 100. So we'll do that. Let's give this a name, QTY. And then over here, I'm going to simply say equals QTY. So for those people that know Excel, this is all part of the standard for the course. And then I'm simply going to come in here and multiply this by that. And that's going to be my total cost. Let's sum each of those, to sum that and sum that, and call this total. And we're good to go. Why is this interesting? Well, this is me using the query data to build myself a little calculation on the side. But in many respects, what I'm doing is I'm actually building a very basic business model. Why? Because my quantities that I'm going to simulate here in the what if don't exist in the database. Could I somehow come up with a quantity value in the query and then populate the results and add it as a formula to an existing query? Yes, I could. And probably if I was going to make this a tighter experience from a purely descriptive or diagnostic perspective in the analytical tool set, especially if I wanted to visualize it well, would I do it like that? Yes, I would. But this is another way of doing it, and it's something that we think a lot of users are doing anyway, this kind of logic. Okay, so I'm just formatting this, again, showing everybody how this works. And now I have the privilege of saying, well, geez, what would happen if the quantity went up to 200? And I can see the cost there. And I've said, geez, if I said I needed to produce, 200,000 megawatts, I can see my total cost. I'm actually simulating in a super basic way what my total cost would be across the thing. And if I change the region over here to south, suddenly I'm going to get a different projection because all the metrics behind it are going to change. Of course, the quantity in this case is uber simplistic and it's not very exciting, but it shows you what it is. Okay, now we're going to also calculate as part of our simulation, and this is again a demonstration of that business layer logic that goes above and beyond just the query. I want to look at the pollution effect. And the pollution effect is a good example of using some product function in normal Excel, as it is expressed here in Pyramid's Tabulate spreadsheet, which is going to be some product of that array by the amount, the quantity of that array. And you can see me creating the formula there. And if I was to drag and drop that down now, and set up the, again, the formatting so it looks nice, you can see that, of course, that's for carbon monoxide. This one here is wrong. Dust particles, it needs to be that one. And this one needs to be that one. And this one needs to be that one. So we can immediately see that we're able to generate these Excel formulations using our fake quantity values and actually inform a whole bunch of things on the spreadsheet here that I wouldn't do otherwise. So for example, if I said, well, geez, what would happen if I went to, 50,000 quantity megawatts per power source, I can immediately see where my pollution is going to end up. I can see my total cost, the amount of power I'm going to produce, and so on and so forth. And typically I would go there, I want 80,000 because that's the target. So probably I'm too up here, and I need to probably put in, let's say, 15,000 to come up with, 15,000 to come up with roughly what I'm looking for. Even that's too high. So we'll go with, I don't know, 10,000 and so on and so forth. And you can see I'm starting to play with it and work at the pollution and stuff. Yeah, that's not optimal because I'd love for this thing to work itself out. But in terms of a what if analysis and playing with the power of a spreadsheet, I've got all of that. What's fantastic is that the data is still live and hydrated. Again, you look at all these cells that are looking at the data sources, and tomorrow morning, when all the metrics change, the emission standards change, the pollution levels change, or the cost per item changes, which is probably the one that's going to change the most, I can actually read this in maybe from a Python feed from the marketplace, a commodities price of, what is the cost of coal. We can then drive what the cost per megawatt hours and so on and so forth. So it can be a very, very interesting way of doing it. This, of course, because it's virtual and it's sitting inside Pyramid, there's no desktop application. When I hit save, I'm going to call this, power simulation, and I'm done. And suddenly I have now got something that maybe I would share with other people. It's still connected. There is no leak to a desktop application and so on and so forth. If I want to share it with people, I share access to this tabulation experience, and they've got access to it as well. Now, let's do a little bit of black magic here as well. Again, just to show you that it can be done. Let's go ahead and add some data bar formatting to that. So we'll do this like that. And we can do this one just because we can. And we will actually make it a color scale and so on and so forth. Of course, it's the same number, so it doesn't tell you much. But this could be one way of consuming things. Okay, good. It turns out, of course, that this is a really suboptimal way of doing or solving how much power I should produce, partly because I don't just want to sit there and play with the numbers. I need to hit the target. I would prefer to do it at the cheapest possible price and also make sure that the pollution doesn't exceed the limits set by the organization up to that number, if you will. So this is definitely not the best way to come up with the calculation. So this is going from hocus pocus manual what if, and I want to upgrade this to machine driven what if, or what is called an optimization. And whatever the quantities are, that is the result. That is what I should produce per power source, per region, to hit the different requirements, the target, the amount, the cost, parameters, and whatnot. So keep that in mind as we move on from here. Okay, so we've done all of that. Now it's time to upgrade this with the next stage. So let's begin now the solver demonstration to see how this works. So the first part of the solver is I come along, click that button, and I say, it gives me a wizard here to set it up. And if you've seen a similar tool inside Excel, it's built on a very similar idea. The big difference is this is hydrated with live data, and it's something you can share with the users through the same descriptive and diagnostic and other tools in terms of pyramids pipeline in the same dashboarding and publication framework. So keep that in mind. So I want to, first of all, minimize the total cost. That's the primary goal. I must minimize cost, and I want to change the amount of power produced. That's what I'm trying to change. So if I change the quantity and minimize the cost, it's the first set of requirements. Unfortunately, it doesn't end there. There are some constraints. What's the first constraint? Well, the power that I'm going to produce cannot be negative. I can't produce negative power. It has to be above zero. The second requirement that I have to have is the amount of power I produce has to match what I'm required to produce. It's pointless if I don't do that. So the targeted amount that is being generated from the predictive engine needs to match the amount of power I'm going to prescribe from here, the prescriptive engine. The next requirement is that the amount of power I produce per source cannot exceed, that has to be less than or equal to the total capacity of each of the sources. Sounds reasonable. And if I hit the apply button now, we're going to see quite a difference here. We're suddenly going to see that it has come up with the prescribed amount of power per source needed to both hit the target and at the same time keep the cost as minimal as possible. So that was all very easy. But there's yet another another constraint. The next constraint is that the pollution I generate has to be less than or equal to the limits for this region. So that's another requirement. If the apply button now, we're going to get a slightly different mix of requirements. And the next step to contemplate is a few other things that I'd like to do. Another one I'd like to go after is the ability to let the user tweak the amount of power that we're going to do. In other words, the requirements. So I've got some parameters here. The first one is a target scaler, and it's a simple UI widget that is going to go from 95 to 105, something go 5% greater or less than my target. So I'm going to call this the scalar. And I'm going to set the target to being that number divided by 100, just so we turn it into percent. So it's going to go up or down a percentage. If I go down to 95, the target is 71.25. And if I go up to 105, it goes up 5%. That's one requirement. The second thing I want to do is I want to tweak the cost of renewable energy to see how much renewable energy has to go down so that the solar and wind actually makes it into the matrix of solutions, because at the moment it's being left out. It's just too expensive. So I'm going to come over here, choose another parameter called renewable economies, hit the apply button, and it just gives me a range between 15 and 100, 100 being the full amount and 15 being effectively an 85% drop. So what I'm going to say is the cost of the renewable energy is going to be that number divided by 100. And same thing for the other one. We'll just assume the same outcome for both, and that's it. So from here on in, if I was to change the renewable to 100, it's 100% of the price. And if I was to go down to here, it would drop to 30% of the price. And that again gets interesting. Last but not least is I'm also going to try a minimum renewable amount that I need. Let's say some legislation, green legislation, which says that the amount of power I produce from these two, right, needs to be as a percentage of capacity. All right, so that's going to be the number over there. Let's give this a better formulation. And I'm also, my formula is a bit wrong. It should have been this and that divided by that. And at this point, I'm also going to insist that these are my little switches here. I'm also going to insist in my solver equation that the that one, this guy over here, needs to be greater than or less than 10%, so that, you know, from this point, we calculate everything on the basis of at least 10% renewable energy. And you can see the outcomes there. So if I was to tweak this and went up to 100% of the price, you can see I'm just getting the minimum through here. Whereas if price was to drop down to 1/15, then a lot more of the power consumption or power generation will come from solar and wind. So that tells me, wow, I've got to drop the price of renewables dramatically if I'm going to hit 105% of the targeted predicted amount as per the engine, and that's going to be my total optimal cost. And that's just for the south. So great example of using all the tools here, including the live data, to do it. So now watch, if I change this to north, I'm going to regenerate the data that is sitting behind this. New target, new values, new everything. It's also going to regenerate the amount of power I need to produce using the optimization engine. That's the prescription. And again, keeping the price at a minimum just for this region. Suddenly my quantity, what if again on the side here, is entirely useless. This is a fantastic demonstration of connecting not just the descriptive and diagnostic layer with some of the predictive layer, albeit a very simple one, all the way through to the prescription option and delivering results that actually is the decision. That's what you need to do tomorrow morning to run the region's power apparatus. But this is still not the eureka point. The eureka point is I want to share this, and I want to share it with all my users. And we can just assume for this example, I have 4 different users for each of the regions. They don't really want to see this spreadsheet logic. They want to connect to the data sources. They want to understand how the queries are built. They just want to know how much power should I produce tomorrow morning by source so that we're minimizing our business goal, which is to reduce the cost and still deliver the power that the population needs. Oh, okay. So to demonstrate this, I'm going to load up a dashboard. My dashboard here is already pre-cooked. You can see I've gone and set up some formatting for our company, Acme Power. Inside the second slide over here, I've already built in my projection diagram. This is the live data in yellow, the forecasted layer in blue, both backwards and forwards. This is what is driving the targeting. And then just some nice charting here around the assets that we have in the organization and a slicer for the region. And at this point, what I'm going to do is now introduce our power simulation into this. Before I do that, I forgot one thing. I need to highlight this part of the grid, a part of the spreadsheet, and say it's a visual area. This is very similar to like a print area in normal Excel. And of course, when I'm printing anything here, so once I do this, I can drag it onto the screen. You can see the way a little spreadsheet fragment comes in. I'm going to center the grid, and I'm also going to scale it so that it fits. It looks nice. I also want to bring in my knobs, my target scaler, so the end user can fiddle around with the amount of power they want to generate. The renewable economy is a scale scaler, so you can see that too. And because everything is part of the same happy family, it all auto interacts for me. You can see the lines here. So we can see the way this is wired up. We're good to go. Hit the save button. And now, if I handed this to an end user, they would come in and load the dashboard. There we go. Very nice. Logos and whatnot. Click next. And in this dashboard, they would come along and go, well, okay, I happen to be running the North region. First of all, there's the power projection. Here are my statistics, megawatt cost per hour and total capacity for each of the assets in the North region. And over here, I magically have the answer to the question, well, how much power should I produce? As an end user, non-technical end user, this is fantastic. And say, well, geez, what happens if we were running at just 100% of the targeted amount? I can see that. And if renewables were actually closer to what they run today, oh, that's the power I need to generate. Interesting. Maybe if I was from the South region, it'd be a completely different result. That's completely recalibrated again. And maybe in the South, we know that we're able to get the power down to 50. I mean, the cost of renewables to 50% of what they are today. And I can see, geez, I'm not really making a dent in that. It turns out we'd have to keep going. I need to get it down to 30% of what it is today to have a real consumption of renewable energy. And by the way, if the overall power was 5% lower than projected, it would look like that, and 5% higher, it would look like that, and so the story goes. This is exactly what so many use cases represent in the real business world, where I, a data worker building something quite advanced and sophisticated like that prescriptive solver, have to put together. And what so many of the consumers of the outputs from that particular engine need. They don't need the spreadsheet. They don't need the logic. They don't want to see the entire backend engine. They just want to get this little fragment so they can understand how much power they need to produce, together with some nice descriptive charts and analysis to go with it. And that is a completely different approach to the overall decision process. This is a great encapsulation of the entire data factory from beginning to end, albeit a very thin one, because there's many things we didn't show here, but a very, very good one explaining how it all connects. And hopefully, you now have a better understanding of how pyramids tabulate and solve, complete the factory paradigm, and how we're really going to make a shift in the way people use data to drive really smart decisions.